So as we said, keep this picture in mind because we are going to use it later on. And going to the next slide, let's see what LNG is. So there are two types of liquid gas. We have the LPG, the liquefied petroleum gas, and the LNG, which is the liquefied natural gas. The LPG is mainly propane and butane, and this liquefies at 5 bar at 15 degrees, so normal atmospheric conditions. And its density for the LPG is 46.1 megajoules per kilogram or 26 megajoules per liter. And this gas is heavier than air. On the other hand, we have the LNG, and the natural gas is mainly methane. It liquefies, that's the problem for us, at minus 162.5 Celsius when we have it at atmospheric conditions. The energy density is 45 megajoules per kilogram or 22.5 megajoules per liter, and this is lighter than air. So if it's as a gas, it will move up in the atmosphere, whereas this LPG will move at the lower layers of atmosphere. So the contents of LNG are methane, and the percentage will vary according to the source where it comes from. It's usually 70 to 90%. Then we have propane, which is 0 to 20. We have carbon dioxide, which is 0 to 8. Oxygen, which could be 0 to 0.2%. Nitrogen, up to 5%. Hydrogen, sulfide, which is up to 5%. And rare gases, there could be some traces inside the liquid. So this is how it is, let's say, the connection between the carbon molecule and the four hydrogen atoms. The carbon atom, and the four atoms from the hydrogen. At this point, we need to understand that in the transportation we had a number of revolutions. The first happened when the people decided to stop using sails back in the 19th century and start moving vessels with steam engines. The steam engines used solid fuels at the beginning. Then these solid fuels were 100 years ago. They were replaced by liquid fuels, and what we see now is that the LNG, the gas fuel, is the next big thing, the new revolution, which will change the way we design and we operate vessels. The LNG is not something new in shipping. It goes back almost 65 years. Back in 1951, there was the start of the first experiments for shipping liquefied natural gas. Back in 1954, the first LNG river barge was built with a carrying capacity of 5,500 cubic meters with 5 cylindrical balsa-lined tanks. And the barge was named Methane and carried LNG from Louisiana to Chicago on Mississippi. In 1957, Comstock, which was the Conoco and Chicago stockyards, with North Plain Gas Board, started the LNG seaboard transportation study, and they converted a cargo ship to the Methane Pioneer, which was the first LNG carrying, not fuel, carrying vessel. But this was the start of the use of LNG on board ships. So shipping has a lot of knowledge of LNG for the last 50 years. Okay, so it's not something new. So this was the break. We did it already. Let's move to the next part. So, let's compare how easy it is to find LNG compared to the oil. We see that the oil trade and the LNG trade are compared in this slide. You see that the global oil exports are 4 billion a day, whereas the global LNG exports are 500 million a day dollars. So you see that the difference in the investments and the earnings produced by the two industries right now. The environmental regulations, as we said, we had the IMO, which required through MARPOL the prevention of emission of pollutants, air pollutants from the international maritime industry. The first adaptation was back in 1997. We had limits to air pollutants from exhaust gas, including SOx and NOx. And in 2008, we had the extension of designated emission control areas, the ECAs. We need to have in mind that shipping is very important for the global economy. That's why we have it. And we need to, let's say, make sure that the solutions we are using and we are proposing will safeguard and will allow shipping to be a flourishing industry, because it is carrying very efficiently 90% of world trade. And this is something we need to always cherish and remember. So, this is the picture. We, as a ship owners, we have to enter an ECA area. What do we do? Which are the solutions we have in order to meet the requirements? This graph here provides a very good overview of the current situation. We have signs which here do not allow us to emit SOx. We have NOx regulations, and we have here signs saying that we have to be very careful when we say that we should use scrubbers or other scrubber technologies. So here we have various, let's say, solutions, pathways we can follow. We have here the NGO, so using another higher quality marine fuel. We can turn here and go for the LNG, and this is 2015, and in 2016 we have to think more carefully what we are going to do. And here we see that in the future we may have very strict requirements about the SOx, and this will change the ranking of the solutions which we have. The SOx emission control areas, it is defined a SEC area for the SOx and particulate matter or NOx, for all the three types of emissions in this area, in the emission control area, which is subject to proposal from the party to the Annex 6. The existing emission control areas, as we said, is the Baltic Sea. The SOx was adopted in 1997, and it was entered into force in 2005. Then we have the North Sea. It's a SOx emission control area. The relevant dates are 2005 and 2006. The North American ECA areas and the US and Canada, which includes most of the US and the Canadian coast, includes NOx, SOx, and this was done in 2010 and 2012, respectively. And the Caribbean Sea ECA area, including Puerto Rico and the Virgin Islands, and these are both areas in the North America are covering both SOx and NOx. And in the Caribbean ECA area, this was the case in 2011 and 2014, respectively. This is when it was adopted and when it entered into force. These are the limits. You see the California, which is a special case here. The things are more stricter there, but the future is the blue line and the green line. Here, what will happen from now on, that we have the limit of 0.1% for the sulfur. Okay? And these are the NOx limitations. We have the engines here. You see the tier 1, tier 2, and tier 3, which is in the ECA areas and outside the ECA areas. So inside the ECA areas, you see how strict the requirements are for the SOx emission. This is very hard to achieve without using new technologies for most of the engines. So, one solution is LNG. And why LNG? What LNG has to offer? The LNG will offer a reduction of 25 to 30% in the carbon dioxide emissions, CO2. The greenhouse reduction will be about 15% due to methane slip. Then we have the NOx reduction, which is 85%, and that means that this will meet the IMO Tier 3 criteria for in a NOx control area. There are no particulate matter emissions, so the reduction is 100%, zero PM emissions, no SOx emissions, and no visible smoke. From safety point of view, of course, this might be a problem sometimes. There's no visible smoke from safety point of view. So you can see in this chart a comparison between the different fuel types. You see a machinery with a main engine working with heavy fuel oil with 1.5% sulfur, a dual fuel machinery with NGO, and a dual fuel machinery with LNG. You see that when we turn to LNG, we have no SOx. We have let's say 20% of the base value for NOx, and the CO2 emissions are reduced. And when we are using the same, let's say, arrangement, using the MGO, we have here the same CO2 reduced slightly, NOx, and a lot of reduced let's say, the SOx are also reduced significantly. So we can see in this map a comparison for the environmental emissions for alternative concepts for a typical Baltic Sea cargo ship. This is according to a study performed. You can see here that if we change to LNG, we have no SOx emissions. The low sulfur fuel using the existing engine will have low emissions, let's say 5%. Sorry, these are absolute values, 5 tons per year. The conventional fuel using scrubber will be at the same limit, and if we use the conventional fuel, this will give us close to 48 tons of emissions per year. Going to the NOx, you see here the fuel, the LNG fuel is much better from all the other, let's say, available solutions. The low sulfur fuel, the conventional sulfur with scrubber, and the conventional fuel. So you see that scrubbers can solve the problem of the sulfur, but if the area has also NOx limitations, then scrubber is not the solution. Okay. So you see the emissions. You see here that no matter what type of if we reduce the sulfur content in the fuel, we will still have the same CO2 emissions. Whereas with the LNG, the emissions will be reduced. The particle emissions will be totally eliminated with the LNG. They will be reduced by the low sulfur fuel, and the scrubber will help. So you see the ranking between the four solutions. You see that with the LNG, we solve the problem in every respect. So we don't have SOx, we have very limited NOx. No other solution can provide this. We have, let's say, the PM emissions are reduced, and of course, we solve the problem. We improve the performance of greenhouse gases for our engine and our propulsion machine. So, in all 4 blocks, the LNG is the best solution. We will see later on why it's not applied, because there is a price tag behind this, let's say, solution. So, yeah.
Does it also count for methane, the slip?
Yes, slip. Yeah, because the maintenance slip, it increases slightly the CO2 here, because otherwise you have improved savings. But the maintenance slip is something when you have 4-stroke engines. So it depends on what kind of cycle you have, and there are solutions in order to minimize this also.
And does it include, or is anywhere included the life cycle of producing the LNG? So like the whole carbon footprint, rather than we're just considering shipping?
We are considering shipping, because let's say in general you are going to produce this. The thing is, of course, if you like to see the whole life cycle, you have to see the emissions which are produced. But the same, let's say, in the old days, all the oil reservoirs, they were emitting LNG, and because there was no use, they were just leave it to the atmosphere. So whatever, even if you have the conventional fuel, this has some, let's say, penalties for emissions of natural gas in the atmosphere too. So you have to balance those two. So in this table, we are, let's say, focusing mainly on the from the point that we have something stored on board the vessel, and from there on what the performance is with respect to emissions. Okay. So if we have NOx and SOx regulations, then obviously the solution is LNG. This will be we have to start thinking about different scenarios. If we have an operation, a route, where we operate in short periods in an ECA area, then most of the scenarios indicate that the MGO operation with scrubber or MGO operation with the exhaust gas recirculation might be the solution. These are two different types. This is selective catalytic reactors, and the other one is the exhaust gas recirculation. We will revisit this later. If we have long periods in the ECA areas, then the option would be to have the heavy fuel oil operation with a scrubber and a scrubbing system. The MGO operation with a scrubber, the selective catalytic reactors, or the exhaust gas recirculation, or in this case, we start thinking about using LNG as the main scenario and option. Let's see how this is affecting the shipping industry in general. If we take here in this graph the production, the industrial production, the gross domestic product, the world GDP, the world sea trade, and the world merchandise trade, with a base at 1990. This is the 100. These are, let's say, they do not represent values which compare, let's say, the world merchandise trade with the world seaborne trade, because actually the seaborne trade is just a part of the merchandise trade. And if you go before 1990, you will see that they are crossing here, and the one is above the other. We are talking about the way each of these indices changed with respect to its value in the 1990s. So if we go here to the green value, we see that in 2013 the value was close to 250, so 2.5 times the value we had in 1990, which is the base value. If we go to the world merchandise trade, we see that this has surpassed 300%, so it's 3 times more than what we have back in 1990s. So we see here how the progress and the expansion of the different trades has, let's say, performed after 1990. We see here that we have this point where we had a very draft reduction, a very large drop in all these indices, and this is 2008. This is the financial crisis, and you see how this collapse of the world economy affected the trade, and how the world trade is picking up again. This is in order to see how the shipping is actually performing, and how this, let's say, after the crisis, shipping and seaboard trade is recovering and it's continue to develop and increase. I told you before we should think about the trade, the SECA areas, and now we see the major ship routes. If you put in your mind the one table above the other, the one chart above the other, you will see that the existing and the possible future ECA areas are in the most congested, let's say, from frequency routes. So more or less all the routes will be affected when they are approaching land by the presence of ECA areas in the near future. So all the ships will all vessels will have to think how they are going to treat this. Don't forget, as we said, that 90% of the world trade is transported by sea. If we go to the European seaboard trade, we see that the thousands of tons which have been carried by ships in 2010, these are the exports in thousands of tons, and the imports, let's say, the first column, the exports and the total in 2010, and then we see the number of total calls per ship to the ports in the European Economic Area and Russia in Baltic Sea, according to Fair Play in 2011. You see that we have a total of 880,000 port calls annually in the European Union or the EU, and you see that a significant amount of these are in areas which are SECA areas, or they are going to be SECA areas. So the impact of the new regulations to the European shipping is going to be tremendous. In the North Sea, it is also it's already affecting shipping, but it's going to affect all areas around Europe. And this is another picture which says it has similar numbers. The source is Eurostat, and it's the gross weight of seaboard goods handled in all ports in millions of tons. And you see the progress, you see the impact of the crisis, and you see how it is picking up again. Of course, during the last years, we have this small economic crisis. This was before, let's say, the recovery in the Eurozone. You see here that the difference which we have in the various quarters in 2012 and 2013, and how this is picking up in the main ports in the European Union. The one line, the bottom line is for the Europe all with the 15 countries, and the top line is for the European Union with 28 countries. And if we see now the volumes which we have, we see here that the importance which the ports here at the north have, the Dutch ports and the German ports, and you see how the impact, let's say the weight that the North Sea has. You understand that a vessel which needs to approach one of these Dutch ports has to pass through the SECA areas. So in that respect, it will be affected by the new environmental regulations. And the same thing you can see here at the Mediterranean Sea. When Mediterranean Sea becomes a SECA area, all these ports from Spain to Greece and then to Turkey will be affected by the SECA requirements. There is another thing that we need to consider is how long a vessel will stay inside a port, which will affect the quality of the let's say fuel it will burn during this let's say berthing or port stay. You see that the average port time for ships is around 35 hours, but there is a difference. The statistics show that the different country ports for the same vessel, they may have 35 hours port time for in Bulgaria, where we have 24 hours in Greece and Netherlands. And this gives us a picture of how long, let's say, the vessel will stay in port. And if you do some calculations with the average speed that the vessel is approaching a port, you can identify how long it will stay within a SECA area. And this is the LNG, maritime routes and trade. This is the other picture. This is the supply of LNG. You see that we have with the dark blue the exporting countries, and with the light blue the importing countries. You see that exporting countries are Russia, Australia, a number of countries in the Far East. Also, we have a number of countries in the North Africa, the west of Africa, Nigeria, and also some countries in the in the South America, and also Alaska. You see, these are the main exporting countries, and the main importing countries are Japan. Japan affected a lot the requirement for LNG following the tragic accident at the nuclear power station in Fukushima, because they had to change the mixture of energy they were producing. So they started importing large quantities of LNG, and we will see later on this affected also the prices you have in the Far East. This is the LNG terminals which are under construction, and they have been committed. They are under study, and the dockside regasification facilities which exist. You see, there are a lot of places in the Mediterranean Sea, in the south of Europe, and you have, let's say, a lot of uh, places, a lot of terminals, LNG terminals at the north of Europe, uh, which are under construction. We have 22 LNG terminals with capacity of 196 billion cubic meters per year, and another six terminals are were committed when this table was made in 2014, with 22 billion cubic meters per year, and the understudy or plan are 22 LNG terminals with a capacity of more than 160 billion cubic meters per year. And this is the another graph which shows the LNG capacity development. We start from 2007, and we see the existing here liquefaction, the liquefaction under construction, and the proposed liquefaction. Uh, this is the global LNG liquefaction and regasification outlook, and you see how this is picking up, and let's say the drive which exists in the market in order to increase the capacity. Uh, you see, we are here in 2015, and you see the growth is very high and very, let's say, rapid. The storage capacity development is also depicted in this graph. We see the total LNG capacity, including proposed projects, with the gray color, and the LNG capacity existing and under construction with the blue color, starting from 2013. Uh, you see also that the rate here for the building, the storage capacity in Europe is very rapid, and let's say this will affect obviously the supply of LNG to any bunkering stations we will have to use for the design LNG fuel ships we design. So we have the need, we have the supply of LNG, how we are going to do the bunkering. So we need to transfer the LNG from wherever it is stored on board the vessel. There are different ways of doing that. We can do this by, let's say, LNG proper, specially built LNG bunkering facilities. We can do this by truck loading, or we can. There has been also proposals for rail loading. This is the LNG is loaded in rail tanks in this case, and which transport the LNG in smaller quantities. There are also bunkering ships and ship-to-ship transfers. We will see another slide regarding this. This is an overview of the LNG fuel fleet, and we see how this number is going up. The projections all, of course, stop here. This table is, let's say, it was built in 2013. Obviously, new orders arrive for the year, so we know that since then a lot of more orders have been confirmed, especially for specific ship types like the OSVs and passenger vessels, and we will see this later on. The important thing is you see that if you go back to 2003, there were, let's say, one or two vessels then the number of vessels expanded exponentially, and we see that there is a trend here for the use of LNG in shipping. The types of vessels which we have here, this is a condition in 2010, this is a situation in 2014, and this is the forecast for 2018. We see the various ship types, but we understand, let's say, the total number of ships which have been operating using LNG as fuel is 63, and 65% are car ferries or platform supply vessels in Norway. So it's much more, let's say, efficient to use the LNG when you are very close to the production of LNG than if you are, let's say, operating very far away from where the LNG is produced. These are the builders for these vessels, for LNG fueled vessels. You see that there are a lot of companies, especially in the North Europe. There are, let's say, there is a yard here in Poland, in Dansk, in Norway. SDX France has a number of orders. Then we have another company in Norway. In United States, there have been also, let's say, vessels which have been designed for the use of LNG. In China, we have here two yards which have, let's say, on order vessels and vessel which is operated. Here is another shipyard. The STX or SV builders. The another shipyard here in China. Most of these yards are used. There is one also in Turkey, Fosen Group in Bergen, in Norway, in Dansk. The SDX has a lot of shipyards because it was a large group and it has the shipyards around the world. But you see that mainly, if you inspect this, you will see Norway, Turkey, China, US, as and Finland as the main, let's say, and Poland as the main places where you can construct. But there is a lot of knowledge and know-how in building LNG fuel vessels. So, according to a study performed by DNV, DNV tried to understand how shipping would look like in 2020. They projected, this was done, if I recall correctly, 2012 or 2013. They projected that there are going to be 1,000 LNG fuel ships by 2020, and the important thing is that there will be, let's say, the mapping they have done is that there are going to be the technology alternatives. This will cost reduce the cost with the more installations, the more LNG installations which will be done. The annual technology and fuel type decisions per ship will help identify which is the best solution for the ship owner. The fuel price and the regulatory requirements will be a significant, will have a significant impact to the decisions. And then we will have more new buildings to the global fleet and for these new buildings, obviously LNG will be a very good option to use in order to reduce the emissions and meet the requirements. So this will give the results required by IMO, and we see that they foresee that a lot of ships which have not been built according to the present standards will have to be scrapped and removed from the market. The LNG bunker demand, based on the same study, you see here where we have now an existing demand for LNG bunkering. This is based on 2012. You see that the only place where we have a demand is in Denmark, in Netherlands, in Rotterdam area. But the look is that by 2020 we are going to have a significant requirement for LNG bunkering in all the places, in all the continents around the world. We expect that, let's say, one of the major players will be North America with more than 1 million, let's say, cubic meters, which, let's say, could reach 1.4. Europe will be one of the major players, reaching up to 2.2 million. China will step in, and Japan with 0.3 to 0.8. Middle East and India up to 0.7. The South East Asia with 0.4 to 0.7, and Australia with 0.1 to 0.2. Also, South America is expected to have requirements for 0.3 to 0.4 million cubic meters by 2020. The bunkering infrastructure, which exists, is planned, or it has been proposed. You see here, because you have the LNG, you have the demand, you need some kind of facility in order to make sure that you can provide to the ship owners and their ships the LNG bunkering opportunity. You see here that the existing ones, there is one in Brazil, there are more in the North Europe, there is another one in China here, and here in, I think it's Korea. Vietnam. Oh, is it? Yeah. And then we have a number of plants where we have Singapore, we have places in Japan, in China, in North Europe, and also in the US. And then we have the proposal, which are covering North America, the other positions in the North Europe and the South of Europe, and then Dubai in the south part of India, and other places in Asia. So you see that there is a lot of infrastructure which is planned, and it has been proposed to be constructed, and this investment will go ahead if the number of ships is built using LNG. So this is, let's say, a two-way interaction. If more LNG ships are constructed, then there will be a demand for more infrastructure, and more investment will be done. If there is more infrastructure, it will be easier for a ship owner to invest into the use of LNG as a fuel. Okay. Focusing now in the European economic area, we see the places where there are existing bunkering facilities. Most of them are in Norway, as we said. The Norwegians have a lot of know-how, and they were the let's say pioneers in introducing LNG. They have uh, uh, constructed LNG fuel offshore support vessels, and they have also built and they operate for many years, close to a decade, LNG fueled ferries, so passenger vessels. And they have, let's say, the best know-how in the construction and operation of these vessels, and also the port facility, the port authorities, they are very experienced with handling the LNG. We see that there are also places in Sweden here, and we see that the rest of Europe is trying to catch up. Here you see the planned ones and the proposed ones at the various places. You see the south of Europe is trying to catch up also with the new proposed bunkering facilities, and you see that there is one here also in the Turkish Straits, where which is going to affect also here. I think now with the Poseidon Med, the Greece is thinking about building a LNG bunkering facility, and there are some additional thoughts here. The Port of Venice is going to have a proposal for as part of the LNG of the offshore ports in the project for the let's say the for building an offshore port for the Port of Venice. As part of it, they are going to use an LNG vessel, an LNG barge, which is going to have a positive, let's say, reduced footprint for this very sensitive area. Okay, that's all. I'm probably slightly ahead of schedule, so we can stop now and start a break for lunch and be back if you don't have any questions. Any questions regarding whatever we have covered in this session? No? Let me check with the distant learners. Okay, yes, I have a question here. Have you, let's say, first done comments? Yeah, in order to have a stable condition in the market, obviously the LNG bunker demand will meet the let's say the supply will have to meet the demand. If there is an oversupply, this will drive obviously the prices down. But it depends on what kind of vessels do you have. We are going to cover this more about the market in the lectures which will take place tomorrow. Okay? We will have an expert from Ocean Finance covering the market section. Any other questions? Okay. If you don't have any other questions, we can break for lunch and meet in 1 hour. Okay?